vocabulary that's going to be associated with this one. So, just clear warning in regards to there is some good amount of writing for this session, but that we'll get most of this writing out today. So we can talk more about examples. So we can talk more about diagrams and designs, and as we move into next week. So I am front loading it with here with those notes. So one such important idea, first off, is really giving a good picture of what we have. So the first word that we have is a population of interest. So the population of interest. So the key here is we want to find information. We want to gather data. All right. So actually, let me make the gathering data is the big idea here. And we want to gather data, and we want to first be able to identify our population of interest. With the population of interest being everyone slash thing who we are interested in finding a response from for our study. Now notice it's who we are interested in. It's not everybody. Okay. It's not everyone, just that it's a period, but it's everyone who are interested in finding. So if we were talking about, right now, there's just a lot of the stuff behind the vaccines, which is more about the experiments. But if we wanted to find out information about, how this vaccine affects, the elderly. So the elderly would be our population of interest, and it's not necessarily everyone, but it's the elderly, or it's individuals who have not had COVID before, or maybe we are interested on those parties who have had COVID already and have recovered. So when we talk about the population of interest, it's not everyone, period. It's everyone where we're interested. So if this was everyone, this may be our population of interest. And sometimes we just shorten that to our population. All right, that's our population. Gathering data from everyone within the population is called a census. All right. So if you were to collect data from everyone that you're interested in, that's what a census, that's called a census. As you know, right now, or they just closed it up, we were taking the U.S. Census on the population, basically. And that census, the population of interest is everyone who lives in the United States. All right. And so the goal with that census, and the reason why it's called a census, is to get an exact count of where everybody lives. All right. So how many people live within each state? So the question to everybody, where do you live, or do you live in the United States? So the purpose of a census is to ask everybody. Now the U.S. Census is a type of census. Now there are examples on the AP Stats exam where We have to understand that it's a census and not a sample, which we'll talk about briefly. So, for example, if everybody took a quiz in this exam and I start looking at that data, that's a census because everybody has already taken that quiz. So if I'm only looking at that quiz, those quiz scores, then that's a census because I have that data. I have all of the quiz scores. Now, if I was looking in terms of how you score on all exams and you haven't taken all the exams yet, then that one single exam would not be counting as a census because you don't have all of the exams yet. So, 2 vocabulary words right off the back. Let me make sure that I'm really make sure that they've, actually let me highlight them. So we have population of interest. That was a very important word. And then of course we have census, which is a very important vocabulary word that we understand. When we only gather data from part of the population, this is called a sample. Another one. So a sample is when you gather data from part of the population. So not everyone in the population, that's a census, but part. So visually, all right, well, I'll get to that part right here. All right. So when we gather data from part of the population, now there's ways to collect. There's different types of samples, and we're going to get into the different ways that we can take samples and what are the pros and what are the cons of that. However, it should be noted that many samples miss part of the population due to the sampling frame. Okay, so what do I mean by this? So when you take a sample, the goal is that your sample is taken from the entire population of interest, meaning that everybody in your population is able to be collected and included in your exam or in your study. That's not always the case. All right. So the sampling frame is the part, and then this is a vocabulary word. It is the part of the population that is able to be included in the sample. So there's a very famous, let me actually put IE. Dewey wins, just so that you have reference of what I'm referring to right now. During the Depression or post-Depression, I think it was post-Depression, there was a very famous election. All right, just like the kind of that's happening right now. You know, things are happening right now with the United States president election, and there was a very famous one back then. What happened was that people would just like polls. The idea of finding out and predicting who's going to win an election has been going on for quite some time. Um, you, as many people are learning today, when we're collecting data, when we're collecting voter counts in the history of the United States, the president is typically declared before all the votes are in, due to what we have, where it's, as samples. We have samples from everywhere basically, and at a certain point, as we will learn in the calculations, you can be almost certain, 99.999% certain that an outcome is going to occur. Well, one of the biggest things that happens is that before the elections, this data is already being collected, and these are called polls, right? Newspapers, news agencies want to call the election so that they get the, that we were the first to know, we were the first to find out, we were the first to declare. You have all these type of things. So there was tons of polls collected, and they were very accurate to the history, last centuries for the presidential election, century. And the process at which they collected data, and we're going to talk a lot about the process. How did they go about collecting the data? We call this, and what happens is there was what's called there was sampling bias, all right, due to its sampling frame. What happened in this election was that it was pretty much like around the Depression era. They were calling people on phones, on their landline phones, and collecting data about who they were going to vote for in the election. Well, by a landslide, I don't always get who was going to win. Or Dewey is in one of the Republican was Dewey, and the other one was Truman, who was the Democrat at the time, running for the election. So by a landslide, Dewey, the Republican, was going to win the election. Deja vu, right? But they were calling on phones. Well, there was a problem with that sampling frame. So they took a sample and they did really good work on making sure that their sample was taken very well. However, and then we'll talk about this word random very shortly, they were only calling on the phones. And the problem during that time was most people who were poor didn't have phones. It's the Depression. They were bankrupt. They were living in poverty. And most of those people were voting Democrats. Whereas the people who had phones were not all, right? Not all. And this is something we'll learn. It's not never an all statement. More often than the real population, the people with phones, on average, voted more Republican. Those people were more Republican leaning than the real population. So we have what's called bias in our sample, because our sample was only including those with phones, and people with phones are more likely than the general population, not saying 50% or something like that, but they were more Republican than the entire population really is, in terms of percentage wise. So they posted up this picture, and it says Dewey wins, and it's Truman the next day, because the newspaper called the election for Dewey, printed out the newspapers, and said Dewey wins the presidency. While they were way off, it turned out that Truman won in a landslide. Deja vu. And there's a famous photo of Truman in a car holding the newspaper that says Dewey wins, kind of laughing at it. And this was one of the big examples of a very poor sampling frame occurring, and that the sample is only as good as the sample. There are people who get paid major money by understanding that data is only as good as the sample. And if you have a bad sample, if you have polls, then you can't collect, you can't use it pretty well. You can't trust it. And so that's what happened, a poor sampling frame. And so visually, visually what we have in the same thing is that if this is everybody and this is our population of interest, then this is the sampling frame right inside here. Now, ideally, the sampling frame and the population are the same. Now, sometimes that just becomes impossible. There's certain people you just can't reach. And so the goal is always to ask this one. So if sampling frame does not include entire population, then must ask, does the sample frame respond differently than population? Now this is a big thing right here. So this right here is the big idea behind bias. All right, that the response do not, and we have reason to believe that the response, the idea is reason to believe that the responses will be differently than the entire population. And if we know that's going to occur, or we know that's more likely to occur, this is the idea behind bias. And this is a big vocabulary. We'll define it a little bit more. But in a nutshell, it's the idea that the responses that you gather are different than those of the population. So if you think about a number line and you say, well, I don't know, because that's the reason why we do sampling, I don't know how the population is going to respond. I don't know if it's 30% are going to be leaning this, are going to respond yes, or if it's 80% are going to respond. I don't know exactly what it is. But if I have a poor sampling frame, or if I take a sample that's terrible, then what we have is we know that, well, my responses will be less, most likely, at least, less than the population. So if I got a response, let's say 30%, all right, that's what I get from my data. 30% said yes. Well, that doesn't mean the population necessarily is going to be 30% now. We might ask ourselves first and foremost, do I have reason to believe that the population, that my sample would be more or less than the actual? Okay, and I might say, 30%, because of the way the population is, I have reason to believe that my sample is going to read more no's or less yeses than the population. For example, and I will get to this example a little bit more in Monday's lecture, I think. If I were to ask my students, and we were to take a sample of, are you sexually active? And sorry for I'm not asking anybody. Okay, no responses here. It's just an example of a type of question, and we'll talk about how this has a specific type of bias. And some students choose not to respond. Okay, you don't have to respond. Some students answer. There's some yeses. There's a lot of no's in terms of the verbal responses. But I get people who don't answer the question. Now, let's say I collect the data in some capacity. It's completely anonymous. Everybody in the entire class feels very comfortable that if they do respond, that they're not going to get identified. But some students still choose not to answer. Okay, there's two types of bias that can really happen here. First off, people might lie. We'll talk about when they lie and they feel that they can't answer truthfully. That's a type of bias in its own right. And then there's the idea of the people who don't respond. The people who don't respond, I have to ask myself, is there reason to believe that the people who don't respond would answer differently than the people who do respond? Well, when you ask a very sensitive question like I just asked, then the answer is yes. Now, it does not say that the people who don't respond are sexually active. What it means is that it is reasonable to believe that the people who choose not to respond more likely would answer yes. All right? And it could be the opposite way. It could be. That's the idea behind statistics. We never know anything definitively. But because there's the idea that because the person chooses not to respond, it might, since it's an embarrassing, it could be an embarrassing question to individuals. There is reason to believe that the people who did not respond, the subset of people that are, missing from the data, the people who are outside the sampling frame, or in this case, just outside the sample that can't be included in my data, there is reason to believe that those people would respond differently than the remaining of the population that did respond in my sample. And that's what we introduce, and then we call that bias. Any instance where the response of my sample are generally higher or lower than the true sample statistic. Full population truth. Now, I know it's kind of, I'm trying to just word this as best I can. So any instance where it is reasonable to believe that the answer is higher or lower than the true population, that's what we call bias in statistics. All right. So any instance where they are different than the than that. Now, when bias occurs in how the sample is taken, this is referred to as sampling bias. All right, another vocabulary word, sampling bias. And yes, sample statistics. We've done some sample statistics. That just means, the mean, the median, p-hat. And this is bad. Sampling bias is bad. So if we have sampling bias, we need to note that. All right. And there's and truthfully, you shouldn't even believe if there's sampling bias, whatever the results are, you have to take it with a grain of salt. Sadly, most samples suffer from some terrible sampling bias in regards to probably the data and statistics that you read, especially those by most all of news media. They want the data to look better in their own sense, so they ask viewers. And when you ask viewers, that's a very specific type of sampling bias that's very, very bad. And we'll get to that one as well in terms of giving it a name. Well, I'll tell you now. It's called volunteer sampling bias. Very poor sampling frame, first and foremost, when you ask people, our viewers say that, well, first off, that's a poor sampling frame because A, you have to be a viewer. And if you are a viewer to that specific news station, both Democratic leaning or Republican leaning could be, you have a very poor sampling bias, and you would expect, and it's very reasonable to believe that whatever the responses say there, it's probably way higher or way lower than what the true population is. All right. Other things that happen. When bias occurs in how the question is stated, or sorry, yeah, how the response, how the, I don't want to say question, how the response is collected after sample. This is referred to as response bias. Basically, there are two instances where bias can occur. Bias can occur in how you take the sample, and then bias can occur in how you collect the responses. If I were to ask you this question and I say you had to, please raise your hand if you're sexually active, right? All kinds of things wrong. First off, I get fired, right? If I was actually collecting the data, because that's just something that's very insensitive. I shouldn't be asking that question, and I'm not. But when I collect that data, regardless of, let's say, I've already selected who I'm going to ask for my sample. And if I said I'm only asking my stats class, well, first off, that's a poor sampling frame. All right. I'm suffering from some sampling bias because you are a different population. Now, in reference to the question, I have reason to believe that, hey, you are taking one of the most challenging courses in high school. You are taking a college course while you are still in high school. You are probably you're more I want to say more educated than other students on average. So I'm not saying that every one of you is more educated than another student. Just because another student is taking another course does not mean they are more or less educated to you. But statistically speaking, as a population, your responses are probably going to be less sexually active responses than the entire population of students that are maybe not taking this course and are maybe I'm only asking seniors, for example, or only asking high school juniors and seniors, which everybody in here is. There is reason to believe that. So that first off, sampling bias is going to occur because I would feel that my responses more likely are going to be higher or lower. There's going to be more no's in my as a percentage of no's within the class than the entire population of high school students, high school junior and seniors. You can also get into the fact that it could be somebody else can argue the opposite. Your responses are most likely to be higher yeses than the general. Some other person can come around and say, I believe actually your students' responses will be higher than the general population because your students come from an urban school, which, in regards to suburbia might be very different. I don't even know who's more sexually active, and I don't want to know. just for the purpose of the example so that it catches you. So sampling bias is there. It might be too high, it might be too low. You can argue, but you've kind of realized that there's our sample population, doesn't accurately reflect the population of all students in regards to that question. All right, in regards to that specific question. If I were just going to be collecting data on the color of your eyes, then there is no sampling bias involved because there's no reason to believe that the color of your eyes, the response that you give about the color of your eyes would be any different than the population just because you're taking AP statistics. So it wouldn't occur there. Now, the response bias. I asked you to raise your hand. Now we're going to have a lot of response bias. We're going to have a lot of different types of response bias. What's going to happen is that we're going to have a lot of response bias that's going to occur from people not telling the truth. All right, they're going to lie, and they have a reason to lie. So I would suspect that if I found out that 30% said they were sexually active, I would probably think that the answer was probably going to be higher. All right. I generally would believe that somebody wouldn't say, and it could be the opposite. Once again, you can argue that high school students will say yes more often because they want to, look, boast for their friends and something like that. I don't know. But let's say it's less, and the real answer is more. First off, that's a response bias because people are not going to answer truthfully. Incorrect. They're going to answer incorrectly. That could also happen from they just don't even understand the question. If you ever had taken a survey and you go, I guess, I don't know, yes, no, I don't even know what I'm answering yes to. I give an answer and, for example, how many people in your family? And some people would be like, wait a minute, my immediate family, some people be like, I have 3 brothers, 2 sisters, a mom and a dad, and myself. So, I count that up and that's like 7 or 8, whatever the number is. And other people will say, well, in my family, I have my aunts, my uncles, my cousins, I have this. Are you only talking about the people who live in my house? Because my older siblings moved out long ago. And, if you don't understand, that refers to response bias as well. The students who don't respond, you have reason to believe that the students who don't respond would answer differently than those students who do. So because it feels reasonable that the students who just choose not to respond at all, that their responses would more likely be higher, or more yeses. It doesn't, and then you get into that. Just because I didn't respond doesn't mean I'm saying yes, or but it just means that it's more likely. All right. This is what a lot of and we could paint a lot of pictures, and this is why statistics is such an important topic within high school students to take, and in college almost everybody takes statistics courses, because we have to understand there's a lot of prejudice, there's a lot of racism, there's a lot of decisions that just get made, whatever type of singling out a group or not singling out a group that happens. Because people feel or believe generally. Now, sometimes it's rightful, sometimes it's wrong. And even if it's right in terms of what they're doing statistically, it doesn't make it right in the social, emotional decisions we make in this world. Just because we know it's okay to, the right decision financially is to kick the people out of their homes, doesn't mean it's the right decision because these are real people. You can get into a lot of stuff. Some people who are ruthless, and a lot of people who make a lot of money are ruthless, and they make their decisions only based on statistics. They are very, very rich individuals. They might not be the most loved individuals. They make, hopefully you've probably seen some people that are just like, 30%, we can be more effective by cutting out 15% of our population. We can make just as much money. We can make more money by paying our people less, even if they don't like it. These are things that you can make from a statistical standpoint, where if you just picture everybody as not actually human individual lives feeding their families, but just from a numbers perspective, if you only, and that's the thing about statistics as well, if you only make your decisions based on that, there's lots of other repercussions, but that's what a lot of stuff does happen with. So, a lot to digest there. A lot of stuff that I even didn't write down for those individuals who are paying attention. I hope you got. I'll cover a lot of what I just said in writing today, Monday, and Tuesday, and going forward. So we'll talk a lot more about bias then. So now let's talk about how to take samples. To avoid sampling bias, given a strong sample frame, poor frame, often we refer to as under coverage. Another word that's a vocabulary word that I'll talk a little bit more. Under coverage. We usually don't use the word sampling frame. We usually refer to it as under coverage. One part of the population might be, not only we cover both the instance that not only is one sample, one population left out entirely, but we can also talk about the instance that one part of the population is more likely to be selected than another. It's the same idea as a poor sampling frame, same idea. We refer to it as undercoverage. Undercoverage is a type of sampling bias that occurs. Okay. To avoid sampling bias, given a strong sample, samples should be randomly selected from the population. Now, we talked about in our previous topic of simulations of how to use. We used a random number table that we had no clue. We personally didn't have any choice in how those numbers were going to show up or what numbers were there. Even though they're pseudo-random. But we use something, and I talked about how we can use technology, or we can select them into a hat for, you just the popsicle stick idea. We can do that. And most of the times in this unit, we'll more want to describe how we would take the sample and not actually take the sample. So we would describe how we would use popsicle sticks. In our course, we're going to talk about using pieces of paper, pieces of equal size pieces of paper. You could theoretically substitute that with popsicle sticks. You write everybody's name on a popsicle stick and throw it into a large hat. The way I word it typically is you write everybody's name on an equal size piece of paper, because these popsicle sticks should also be the same size. We want them to be equal size, because if some are bigger sizes than others, then the bigger ones are more likely to be selected than the lower ones, which would cause undercoverage. So just as a reference when I talk about that part. So sampling methods. We want to talk first about the random samples. There are many ways to collect random samples. So the first one, the most important one, that is most commonly used, all right, and this is the popsicle stick on its most basic format, is called a simple random sample. You might also I might refer to just simply as SRS. So when you see SRS, it is one of the random sampling methods. It is not the only one. Many people believe that a simple random sample is the only way to take a random sample, and that's not true. And the important word here, of course, random. This is when each individual in the sample, or each individual in population, and hopefully it's population, has an equal chance of being selected. All right. And not only that, but all combinations of selections also possible. So for example, if I took a sample of 5 students within the class, and I put all your names, I write all your names on equal sized pieces of paper, I put them into a large hat, I shake up that hat, and I select 5 names. This would be an example of a simple random sample, an SRS, because everybody had an equal chance of being selected each time I pulled one of them. And it is possible, for example, that I choose all 5 are girls. And you're like, oh, all 5 are, well, it's a simple random sample. In a simple random sample, I can get all 5 girls. That is a possibility. It would be a bad possibility if, for example, if I was collecting data on your favorite music group, right? And that was the data we're collecting on. And there's no bias because it was random, but we would have a lot of variability. All right, we're going to talk about that issue of variability in a future lecture as well, because it is possible I get all girls and then I get all of these, you know, this one artist or band or music genre that is probably not as reflective of the population, but we would have very large swings. I could get all boys who like one specific one girls, maybe it's not even gender-wise. I just get I pick in my sample 5 people who are very much the same type of person, and so I get one of the extreme responses. Explaining how to take an SRS. So one of the AP exam questions will be, how do we take a simple random sample? Okay. Well, you could use a random number table explanation. You could talk about a random number generator. But we're not going to use these methods to explain in this course. So you could explain just like we were doing like a simulation where, you know, you assign everybody a number, you know, these numbers, and then you use a random number table, and then you select, and then you have to ignore repeats. You can do that. You can technically actually do that. And then you stop when you selected 5 unique individuals. However, the one that we are going to use is the large hat method. And what that means is, in an explanation, is that we are going to assign each person, and you know, it might not be a person, it might be a thing, a number 1 through n, however many in my population. Write down on equal size pieces of paper, it's the popsicle sticks, mix well. That's a very important part to stay, is mix well. That's the randomness part. Then select blank. This is however much you want in your sample size. So when I ask you, explain how you would how you would do a simple random sample. Whenever it says to explain how, this is what you would do for a simple random sample. Missing a page. Okay. I'm going to cover one more. I'm going to adjust the homework. Don't worry about it. I'll adjust the homework. Covered a lot today. 2. And once again, this is a random sample. Okay? This is called a stratified random sample. However, we might just say stratified. Most people forget that this is still a random sample, but it's a stratified random. We sometimes just refer to it as stratified, and then they were like, well, that's not random. It is a random sample method. All right. In a stratified random sample, homogeneous subpopulations are identified in responding on average different from each other in regards to the response variable. This is more in terms of why. So why do you take stratified random samples? Well, we identify that in regards to the response variable, we have two types of populations that I can identify, most commonly male, female, but that doesn't mean that you stratify for male, female always. That if we feel that the response, the data that we collect from one population, and it's really when we talk about the response, we're talking about the response distribution. We're talking about the distribution of responses would be drastically different from one population and the other. For example, we've talked about these before. Heights. If we were collecting students' heights, well, generally, males are taller than females. All right. So now, doesn't mean all males are. We got some short males. We got some tall females, right? Generally, the males would be responding different than the females. All right, with the males kind of being like their own subpopulation that are very similar to each other, and the females being generally similar to each other as well, but they still have some span and variability within each. We call this homogeneous because they are, they are basically, taller individuals, and they are generally shorter individuals in regards to the response variable. We would not stratify if we were collecting something like MCAS scores. All right, if I was collecting data on MCAS scores, there is no reason to believe that males respond differently than females on MCAS scores. So there's no purpose in stratifying there because the response variable, which is MCAS scores, doesn't relate to that gender. We don't have reason to believe that there's a relationship or bivariate data between the two. Now, if we were there's other instances where we might be able to stratify for 9th grade math class. All right, we can stratify for the middle school, the students' middle schools. We might believe that some middle schools had taught material that other middle schools didn't, so then maybe we can stratify for that. But first and foremost, and this has been a question, why would you stratify, or what would you stratify on? On the AP exam, they're going to be very explicit, and they're going to say something in the question that's going to be like, you have 4 different grade levels. Okay. Oh, well, most likely we're going to stratify on grade levels. And then you have to say, in the questions like, we're talking about the school start time. And, we're going to ask the high school students, and there are 4 grade levels within the high school: freshman, sophomore, junior, senior. They're telling you basically that you're going to stratify on those ones. And the response would be because there's reason to believe that 9th grade students would want to start school earlier, where the senior students might want to start school a little bit later. There's reason to believe that, or it could even be the opposite because the seniors have to go to work, and so they want to get out of school a little bit early. You can argue on that, but that's where it has. As such, simple random samples from each strata. Okay. So when I said subpopulations, we refer to these as strata, are collected. So I might want to ask 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors. explaining. Write the numbers. So first off, we number them. I'm running out of time, I know. We number and we write the numbers on equal size pieces of paper. Place each strata, each group, into separate, I'm almost done here, I know it just reached 10:01, separate hats. And then you select blank, N from each hat, or each hat. And it should be noted, I forgot to say, don't forget, mix well. I covered a lot. There was a lot to write. There was a lot to digest. As such, I'm deleting the homework. No homework over the weekend. Thank you for staying with me all the way to 10:01. Please digest what I just said. We will continue talking about this on Monday. Once again, sorry for pushing you a lot today on a section asynchronous day, but as such, I'm just not going to assign any homework tonight. Take care. Have a good weekend. I'll see you on Monday.